So we are working with shell expansions. Let's see an example of some shell expansions that we have seen also in the last lesson. So this is one thing that shell can expand, and we'll see how it is expanded. And also the shell can expand these curly braces as well. And also another shell expansion is command substitution. And another shell expansion is arithmetic expressions. So in this case, the shell, first of all, is going to replace this tilde with the home directory of the current user, my user in this case, user one. And then shell is going to expand this star with any characters, and it is going to use this as a matching pattern. So it is going to match all the files. It is going to find all the files that match this pattern in the current directory. And this expression will be replaced by the result. In the current directory, we have these two files with extension .txt. So the first expression is going to match these two files, and then the second one is a curly brace extension, and these are two alternatives, and the shell is going to replace this expression with the first alternative space the second one, and the third shell expression is command substitution. So what comes after this dollar and parentheses is the command, and then the closing parentheses. The shell will execute this command and will replace the whole expression with the result of the command. Since this is just a simple echo foo, the result of this command is just foo, which will be displayed on the screen. And the shell will replace this expression with just this text, foo. And this is an arithmetic expression. The shell will get the expression that is inside this double parentheses, and will evaluate it as an arithmetic expression, and will place it will replace this expression with the result. So let's press enter to execute this command. So we see this is the result of the first expression. It has been replaced by the shell, and this is the result of the second expansion. This is the result of the third expansion, and this is the result of the fourth expansion. We have seen also the double quotes and single quotes. We can use double quotes in a command. And let's see what is the effect of double quotes in shell expansions. So if we include the argument in double quote, these wildcards are not expanded. Also, these curly braces are not expanded. But the command expansion will be done, and also the arithmetic expansion. In general, expansions that start with a dollar will be performed if the expression is enclosed in double quotes, and the other expansions will be disabled. So these double quotes disable some of the expansions, but not those which start with a dollar sign. Now let's try the same, but with single quotes. In this case, we see that also the expressions that start with a dollar sign are disabled in this case. So these expansions are prevented. by the single quotes. So we can use these double quotes and single quotes to prevent some expansions in case that we want to prevent them. And also, this is another command expansion. We are using this command calendar, and the output of this command will be replaced. Will replace this expression. But we see that because of the way that shell is processing the input, it discards the empty spaces, and so everything is passed as an argument to the command echo, and the command echo will display them with a single space in between. So the result of this happens because shell discards the white space between two arguments. So if we say echo 1, 2, and if we say echo 1, 2, it is the same thing. So this is still considered as a separator. It is the space, it is considered as a separator, and it is discarded by the shell. But if we use double or single quotes, or single quotes, this is considered as a single argument, and the spaces are preserved. And this is the argument that is passed to the command echo, and echo will display it. And the same thing happens with single quotes as well. So still we have a single argument that is passed to the command echo. And we can use this for preserving the spaces in the output of the command call. So we want to display the output of the command call, but preserving the spaces of this output. So we are enclosing it in double quotes. And in this case, this is the one argument that is passed. This whole string is passed as an argument to the command echo, and it is displayed. Now, double quotes are the right quotes to be used in this case, because if we use single quotes, then they will prevent the expansion of this $sign. So they will prevent the command extension. So if we try with single quotes, we don't get the result that we want, because single quotes prevent this command extension. So double quotes are the correct way to do it, using double quotes. And we can prevent the extension of variables also by using a slash. For example, like this in front of the $sign. Let's see this other example. The balance is $5.00. Now, what happens if we try this command? The shell will recognize this $5 as a special variable, and it is trying to replace it with the value of this variable, but this variable is not defined, and its value is empty. So it is replacing it with an empty string. We can prevent this expansion by using this slash in front of the $sign. So in this case, because of the slash, this $5 is not considered as a variable. And of course, we can also use single quotes to prevent the expansion of this $sign in this sentence. And the double quotes will not work in this case, because with double quotes, variables are still expanded. So whatever starts with a dollar still will be expanded by the shell. So either using single quotes works, or preventing the dollar putting escaping the dollar sign with a backslash. Now, if we use this /a/mb, if you know C programming, you know that this /n usually stands for new line, for the new line character, but the command echo does not interpret it as a new line character. In order to tell the command echo that it should interpret some escaped characters as new line, we can use this option -e. Now, with this option -e, this /n will be considered as a new line character, as a special character. And also, this is true with /t. /t is for a tab. So a tab is a big space, for example, 4 spaces or 8 spaces. So the echo is printing A, and then this is a tab, a big space, and then a B. Now let's start with environment variables. So there are some environment variables defined in the shell, and we can see a list of these environment variables with the command print environment. It is a bit long, so we can view it page by page. And we see this environment variable shell, print working directory, login name, home, language, etc., etc. We can also use the command set to see a list of environment variables. And now we see that the output of this command is a little bit longer than the command printf, because it also includes other things, for example, functions, etc., that are defined in this environment. So we see these bash functions here. So the output of this command is longer than printf, because it includes everything. It shows everything in the environment, not just the variables, but also other things as well, like functions. Okay, let me quit with Q. And if we want to show a single environment variable, the value of a single environment variable, then we can either use print and then the name of the variable, for example, user, or we can use echo and then $user. So they have this printed user and this $user show the value of this variable, which is, by the way, the current user that is logged into this shell. And some other environment variables are echo home, $home. This variable keeps the path of the home directory of the current user, which is /home/user1. Another environment variable is print working directory, and it keeps the current directory. For example, if I go to downloads and try again echo print working directory, so it is showing the current directory. It is the same as it gives the same result as the command print working directory. And echo home is the home directory. So they are different. They are not the same. And the variable shell, $shell, shows the current shell that is being used, which is this one, /bin/bash. It is the bash shell. And the variable lang shows the current language, the language of this environment. And another environment variable that is important is this one, our path. The path environment variable keeps a list of directories separated by semicolon. And it is the list of directories that are being searched by the shell when it needs to execute a command. For example, if it needs to execute the command ls, then which program should it execute? It first of all looks at the first path in the list of directories that contains this variable. If there is no such program in this directory, then it is going to look into the second directory. If it does not find it there, then it is going to look in the third directory on the path. And if it finds it, then it executes this command. And the command which shows us in which directory is this program, in which directory is located this program. And also the command which uses the current this path variable. It is looking at the first directory, it is looking at the second directory, it is looking at the third directory, and it actually finds it into this directory and prints that this is the program that will be executed when we type the command ls in the prompt or in the shell. Now, where do these environment variables come from? Where they are declared? So they must be declared somewhere or somehow, and they are declared in some configuration files that the shell loads when it starts. So when we start the shell, it is loading a couple of configuration files, and among other things, in these configuration files there are some variable declarations as well, and so this is how these variables are created. And actually there are two kinds of shells in Linux, a login shell and a non-login shell session. A login shell is the one that we access when we give a username and password. For example, when we log in here, first we give a username and then we give a password, and this is a login shell, the shell that we are currently using. Another type of shell is a shell that is started, for example, from a menu. If we have a graphical user interface, we click on the shell icon to start the terminal and the shell program, or we access the menu and then find the shell program. This is a non-login shell because in this case we don't provide a username and password to access the shell. Or we can start a non-login shell by just running bin bash. Now, it seems that nothing changed, but actually I just started a non-login shell, and which was started from the current shell. So I exited from the nested shell, and I'm back to the original shell. And the configuration files for a login shell are located at etc profile. So this is for a login shell. So when we start a login shell, this file is loaded first. And let's look at its content with the program Nano. Nano is an editor which can be used to look at the content of the file or to edit it. So this is a configuration file for the shell that is loaded when the login shell is started. Now to exit from Nano, we press Control X to exit or to quit. And another configuration file. This is a global one, and there is another there is a local configuration file with this name. So this is local because this can be different for each user, and that one is the same for all the users on the system. So let's look at the content of this file as well. So again, we see some definitions. For example, here we have a modification of the variable path, and here again there is a modification of the environment variable path. And to exit from Nano, again we press Control X. So for a login shell, we either when we start a login shell, this configuration file is called /etc/profile, and then this .profile in the home directory is called. For a non-login shell, we have the configuration file etc --rc. So this is loaded first by the non-login shell. And again, we see some definitions here. And here we see environment variable that is declared, PS1, and we will see what it is in just a few minutes. And again, let's quit with Control X to exit. So beside this one, there is also the local configuration file .bashrc. And if we look at the content of this configuration file, again, this is a variable declaration. So this his control, his size, his file size, they are declared. These variables are declared in this configuration file. And so some other declarations as well, aliases, declarations of aliases. And so on. They modified buffer? No, I modified it by mistake. And let's check, for example, okay. So this variable is declared in one of these configuration files. Actually, when we run login shell, in the configuration files of this login shell are included configuration files of a non-login shell as well. And so this one is included as well. So if we need to change something or to make a modification, then this is the right place to make the modification, because this configuration file will be loaded both in a non-login shell and a login shell. So the modification will be applied in both cases. And let's see how we can modify an environment variable. This history size is an environment variable that shows how many commands are stored in the history of commands. So history of commands is a list of commands that is stored in a file. It is stored first on the RAM, on the memory, and then when we log out from the shell, this is appended to this history file. But this variable shows that this list does not grow indefinitely, but it keeps only the last 1,000 commands. And suppose that we want to change this one and to make it 2,000. Then we can edit the file. Actually, we can modify it right away with the command export list size equal to 2,000. And now if I check the value of this hist size, if I check the value of this variable, it is 2,000. But this modification that I did here is temporary. It is just for this shell session. Next time that I log in, the configuration files will be loaded, and this variable will get the value that is in the configuration file, which is 1,000. So next time it will still be 1,000. If I want to make this modification persistent, so that each time that I log in, this variable has this value, then I have to make this configuration in one of the configuration files. And we said that the right place to make such configurations is this file. So I can edit this file. And go to the end of the file. And type export hist size equal 2,000. And this equal is without spaces before or after it. So there are no spaces allowed, because shell interprets spaces to separate the arguments from each other. So in this case, we should not use any spaces around the equal sign. And now to save this file, I can press Control O, write out. Let me try Control O. File name to write. Okay, this is the file name that should be where it should be written, and press Enter. And now exit with Control X. Control X. Control X. So next time that I log in, this configuration file will be loaded, and this variable will have this value 2,000. But I can also load this configuration file right now with the command source. So this command source is going to kind of include this configuration file in the current shell, which means that all these lines will be executed one by one, and the last line is this one, and so each size will have the new value. It has the new value that we gave it. Another important shell variable is this one, PS1. And this PS1 contains the format of the prompt. So this is the prompt, and this is the string that instructs shell how to display this prompt. This looks a little bit complicated, but it doesn't have to be so complicated. It can be simple. And before we start to make any modifications to this variable, first of all, let's save it in a backup variable. And let's say, for example, that we are defining this variable ps1 all, which gets the value of ps1, and we can also include it with double quotes. Now let us check the value of this one. Echo. So it is the same. It is the same value as the value of PS1. So in case that we make some mistake and we break the prompt, we can correct this mistake, and we can revert back to the back value of the prompt with this command. So we can correct the prompt with this command in case that we make some mistake and we break it. Now let's try to change the prompt. To change the prompt, we just change the value of PS1. For example, let's say that I am giving it this value. Now you see, this is the prompt. So now this is the prompt. It is very simple, but it's just a prompt. So we just changed the prompt by changing the value of this variable. Now let's try another value of the prompt. PS1 gets the value, this $, so that it is not interpreted by the shell, it is not expanded by the shell, it is a little $. And now I get this prompt, which is just $, and an empty space. So just $, and an empty space. And let's make the prompt a little bit more complex. PS1 equals /A space /H, and then space and $, and space. And now the prompt is this one. Now you can understand that this /A is the time in this format, and this /H is the host name. The host name is the name of this host. And then we have a $, and a space here, a $, and a space. And let's try a more complex prompt. PS1 gets the value, /EU, and then an @ sign, and then /H, and then a space, and /W. And then let's also add $, and a space. So this is the new prompt. So this is a literal character, this less sign, and also this is a literal character, just a greater sign. And this slash u is this the user. Slash u represents the username or the user ID of the current user. And then we have this @ sign, which is a literal character @ sign. And then we have /h, which is the host name. And then /w, which is the current working directory, which is this download. For example, if I go to the parent directory, now this /w stands for this tilde, which is the home directory. I go to totals, then oops. Then this is the current directory. For example, let's go to another subdirectory. Okay, actually, this is the last part of the path of the current directory. So let's go to the home directory, and now let's suppose that we like this prompt, and we wanted to use it also the other times. So when if I make a logout from the shell, then this modification of the prompt is lost. Why? Because this variable ps1, next time that I log in, will get the value from the configuration variables, and it will get again the previous prompt. For example, let me demonstrate it. So I make an exit. And now let me connect again. User 1. And now you see that the prompt is just the previous one. The modification of the prompt that we did is not reserved. In order to make it persistent, we have to add it to the variable, to the configuration file .bashrc. So I have to modify this configuration file, and then go to the end of the file or somewhere, and then change the prompt, export ps, or even without export, just ps1, like this. And then whenever I log in, I'm going to get the new prompt, because this variable will be defined in this configuration file. I don't want to do it right now. Let me write Ctrl-O and then exit. But this is how we can make the change of a configuration of an environment variable persistent. So we have to add the definition for this environment variable in this configuration file .bashrc. Now we will start another topic, which is searching for files in a Linux file system. One of the easy ways to search for files is locate. And let's say that I want to locate something that contains a file that contains bin zip. And it is listing all these alternatives, and all of them contain this bin zip. And if the list is long, I can combine the output of locate with grep. or I can filter it with grep. For example, if I just locate bin, there is a very long list of files that contain bin, but I can filter it with grep. So from all that long list, we grep only the files that contain the word zip, and we see the result here. And actually, we also have this unzip file, so we can filter it further and say grep -v unzip. If you remember, this option -v does the opposite of search of the regular searching. So it does not display the lines that contain unzip. It displays all the other lines, but not the ones that contain unzip. Usually, the command grep displays all the lines that contain this word. But if you use the option -v, it displays all the lines that do not contain this word. So in this case, we are filtering all the lines that contain zip, and then we are removing from the result all the lines that contain unzip. So we see that these unzipped lines have been removed from the output. The command locate actually uses a database, or an index. So there is a command that searches all the file system and indexes it. And then when we use the command locate, it is getting the results from this list. And so the output of the command locate may not be very up to date, because it shows the results since the last indexing of the file system. Another command that is used to find files is the command find. And the command find gets the results, is searching at that moment that we type the command. It is searching the file system at this moment. And the command find gets as an argument the directory that it is going to find. For example, let's find all the files and directories in the home directory. So this is the list of all the files and directories in the home directory. And we can filter the output of file by using, for example, the option type. So we are searching at the current directory, but with type D, it is going to display all the directories. And with the type F, it is going to filter all the files, to display all the files. So there are so many files in our current directory. All the files are included, even the hidden ones, as we see here, .xauthority, etc. And there are this many directories in our home directory. And if we search for everything and count them, so find everything and count, the result is 828. So this includes all the files and all the directories. If we add up these two numbers, actually they do not match exactly, because this one includes also this and this. So this directory, the current directory, and the parent directory. So this number is bigger than the sum of these two. It is bigger by 2. What other filters can we apply with the command find? Let's say that we are searching. Okay, let's find on the directory etc all the files. And we also see this message is permission denied because we don't have read permission in all the subdirectories of that directory, but we can use the command sudo. And in this case, it is going to, it will be able to read everything in that directory. So there are this many files in the directory /etc. And let's find all the files that have the name. So let's find all the files that end with .conf in the directory etc. So we are still searching in this directory. We are finding all the files, but there is an additional condition that the name should match this pattern, star.conf, which means that all the files that have an extension .conf. And so we see that all the results have this extension .conf. And let's count them. How many of them? 306 files have the extension .conf. And now we can apply another filter to this find command. For example, let's suppose that we want to filter them by size minus 2k. And what this means? What this means is that all the files that have extension .conf, but also whose size is less than 2k. This is a kilobyte. So all the files that are of size less than 2 kilobytes. Now let's find all the files that are greater than 2 kilobytes. There are this many files, and let's say that we want to find all the files that are exactly 2 kilobytes, not more than 2 kilobytes, but exactly 2 kilobytes. So there are this many files that are exactly 2 kilobytes. And if we compare this result with these three results, or these three numbers with this one, so this is finding all the files with extension.conf, and there are 306 of them. Now, if we add up these three numbers, we should actually get 306. I think it is correct, but let me try to use a calculator. Okay, the result is 306. So all the files less than 2 kilobytes, all the files more than 2 kilobytes, and all the files equal to 2 kilobytes. If we add all of them, then we get all the .conf files. Actually, the command find has many kind of tests. For example, this is a test. Is it a directory or is it a file? This is a test. The file name matches this pattern. And this is a test. The size of the file is less than or equal or more than this number. Let's see some other examples that are using some other tests. For example, find in the home directory. And I will explain what are these parentheses. But let me type first the command. So the type F. I'm searching for a file, and then this is an operator not, and this is a filter for permissions. And then I'm closing the parentheses, and then this Boolean logical operator OR, and then I'm starting another parenthesis, and then type directory, and logical operator not, and permission 0700, and then I'm closing the parenthesis. Now it is finding something. Now, what does it mean? First of all, we have two expressions here, this one and this one, and they are connected with the logical operator OR. So the results will be displayed if they match this one, and also the files or directories or the results that match this expression. And we are using we are escaping these parentheses with a slash, because a parentheses have a special meaning in the shell, so they are interpreted in a special way by the shell. And so in order to prevent shell from interpreting it, we are escaping it with this slash. And also notice that it is important to leave always an empty space around the parentheses and around everything, because the shell will not interpret correctly. If there is no space here, for example, then the shell will take all this as a token. But a shell, a space is telling the shell that this is a different token and this is a different one. And so this filter permission. So we are finding all the files that do not have this. Not is a negative logical operator that not have permission 0600, and this 600 is the permission read and write by the owner, and nothing for the group and nothing for everyone else. So this is like a good permission, because the file is properly protected. And so with this filter, we are finding all the files that do not have good permissions, and also here with this other expression, we are finding all the directories that do not have good permission. So a directory that have permission 700 has good permissions, because the owner can do everything on this directory, and the group and other users can do nothing. So with this find command, we are finding we are finding all the files or directories that do not have good permissions. And now let's see that we can also apply some. The command find, after finding an item that matches all the filters, by default it prints it on the screen. But we can do some other actions as well besides printing. For example, let's create some test files with the command touch test. So I'm creating these example files. So I am creating these example files with this command. The command touch just creates an empty file, and this is a shell expansion. We have seen it, curly brace shell expansion, and this makes it is going to replace this pattern with 3 arguments, one for each item inside the curly braces. So this command is actually the same as typing. It is the same as typing test1 dot bug, test2 dot bug, test3. But of course, this is more concise. We can type it more easily. So we have these 3 files with the extension .bug. Now let's try to use the command find to find all files that have the extension So we are finding all the files in the current directory that have the extension .bug. So they match this pattern star.bug. And now to this command, I can add this action delete. Now, if there is no action, by default the action is print. It is going to be printed. So it is the same as this one, print. So everything that is every file that is found to match these filters is printed on the screen. But I can use the action delete instead. And now, if I see, there is no such file. They are deleted. So every file that is found is actually deleted. And we can also combine 2 different actions. For example, let's create again. Let's create again these 3 files. So we have these 3 files. And now, instead of just printing using the action delete, we can use the action print and then delete. So in this case, it is first printing the item that it is found, it finds, and then it will delete it. And if we look again, they are deleted. They are not there anymore. And we can use some other command as well. So first of all, let me create them again. So we have these files. And now, instead of actions print or delete, I can use the action exec, and then there is a command that comes after it. For example, I can use the command rm, and then this, and then this. And actually, this stands for the file that is found. So this is the command remove. This stands for the file that is found, and also we need a semicolon at the end of the command. But because the semicolon is interpreted by the shell itself to separate commands from each other, we are escaping it with this slash semicolon, so that the shell does not interpret it, but it passes it to the command remove. And also, these curly braces are interpreted by the shell. So in order to prevent the shell for interpreting them, we are including them in single quotes. And so again, these files are removed. And if we use instead, so let me create these test files again. So here we have them, and then this is the previous command where we removed all the files that were found. But instead of, if we use instead of exec, we use OK. Now it is going to ask for every action that it is done. So it is going to ask for confirmation. So remove, yes. Remove test2, no. Remove test3, yes. And if I list, now I will find that only this file has been kept and the other two are removed. And another way to execute some commands on the files that are found. So we find some files with the command find, and then we perform some action on all of these files, is this one. So we have created these files. Now I find in the current directory, type file, and then name star.back. Now I can pass the output of the command find. The output of the command find is this one. I can pass it to xargs and then another command. For example, let's use echo in this case. Now, what is happening is that xargs takes the input from the previous command and sets it as sends it as arguments to the following command. So actually, we have echo and the output of command find, and the result is this one. But instead of echo, we can use some other command, for example, lsl, and press enter. So again, the result is that we will have lsl, and then this xargs is going to take the output from the command find and will list it as arguments to the following command, and we'll get this result. And another command that we can use is xargs, for example, remove, and it is going to remove all these files. So they are already removed. So in the next lesson, we will continue again with more examples about the command find. But for the day, let's close. Let's end the lesson. Unless you have any questions. Is there any question? Okay.
No, I like the command BC. I didn't know about it.
Okay, we will see more about the command BC later. Okay. Okay, then let me close the registration.